Warm welcome to lecture 19, which is based on working principle of alternator. Myself Dr. Satyadharma Bharti, I am professor at Rungta College of Engineering and Technology, Bhilai, and in today's class I am going to deliver the lecture on the topic working principle of alternator. The basic purpose of the alternator is to generate electricity. It is a device which converts mechanical power into electrical power. Just recall the schematic diagram of any generating station. It may be hydel power generation, it may be nuclear power generation, thermal power generation, or any other type of generation. You will find one thing which is very common. Just before the alternator, you will find one prime mover which is used to rotate the alternator. So, when we are rotating the shaft of the armature, inside the when we are rotating the shaft of the alternator, the magnetic field is rotating, conductors are stationary in the on the outer part which is stator, and hence there is some relative motion between magnetic field and conductor. According to Faraday's law of electromagnetic induction, whenever there is relative motion between magnetic field and the conductor, an EMF will be induced in the conductor. This is the basic principle. So, how the entire process is set up in the alternator, we are going to discuss. We will also derive the equation for generated EMF. We will discuss different type of alternators, whether it is salient pole or cylindrical rotor. We will also go through the different methods of regulation and some other basic terminology related to alternator. So, basically we are having one machine known as synchronous machine. If we are feeding mechanical power to it, it is working as alternator. You may call it AC generator or synchronous generator. What we are doing? We are simply rotating the shaft of that machine at synchronous speed, at fixed speed. Whatever may be the prime mover, it may be steam driven, it may be water wheel, Pelton turbine, Francis turbine, or the shaft may be rotated by diesel engine. It hardly matters. We are rotating the shaft of the alternator, and the armature is exporting AC power. Now, in the same machine, if we are feeding the electrical power, then it will work as synchronous motor. In that case, based on the frequency of the input supply, it will start rotating at synchronous speed. So, in any synchronous machine, we are having two important things. One part is armature, another one is field. Now, we are having only two options. We can place the armature on the stator, or we can place it on the rotor side. Generally, the field winding is placed on the rotor. The armature winding is made stationary, and there are certain advantages of this making a stationary armature. So, field winding is always energized by DC. We are feeding, whether it is synchronous motor or it is alternator, what we are doing? We are feeding DC power, whereas in case of armature, either it is exporting AC or it is importing AC. In both the cases, the synchronous machine is doubly excited. It is doubly excited machine. Just recall the induction motor. What we are doing? We are feeding 3-phase supply to the stator of induction motor. As a result, what will happen? There will be rotating field, and then EMF will be induced in the rotor bars. So, there is only one type of excitation, AC excitation, but in synchronous machine it is doubly excited. So, this is one of the major difference between synchronous machine and induction motor. So, we were talking about the advantages of stationary armature and the field rotating. When we are talking about the alternator, definitely we have to produce huge amount of power. So, high power armature winding, it is placed on stator, and the other part field, it is made rotating. So, this is true for machine having higher ratings. However, for a small machine, we may use vice versa. We may provide the field on the armature, and the armature may be kept rotating. After all, it is working on Faraday's law of electromagnetic induction, and there should be relative motion between magnetic field and conductor. So, as far as the principle is concerned, there is no problem on keeping the armature stationary or rotating, but why we are making the armature stationary, we will discuss few points and we will come to the conclusion. So, first advantage is the economy, one of the major part. Suppose we are keeping armature on the rotor side and field poles are fixed. Now, what will happen? If we are talking about the alternator, EMF will be induced in the armature and we are keeping the armature rotating. Now, we have to extract the power, we have to import the power. So, for this purpose, we will need 3 slip rings, because we have to generate 3-phase power. So, 3 slip rings, minimum 3 slip rings are required, otherwise for neutral also. So, in that case there will be requirement of 4 slip rings. So, just consider if one point is star connected and we are considering say 250 MVA alternator, 250 MVA, it is having a huge power capacity, and the generating voltage is of the level of 33 kV, 250 MVA, and the armature is connected in a star. So, we can easily calculate the line current for 250 MVA, 250 into 10 raised to power 6 divided by root 3 into 33 kV means 33000. So, on solving we are getting 4373.99. Generally, the alternator it may work on some overloading also. So, about 500 ampere, this is the rating of slip ring, this much current one slip ring has to handle, 5000 ampere, just imagine. And we are having very limited space on the shaft. Now, one important requirement is there, the slip ring, and it is placed on the shaft. So, we have to provide certain insulation between this slip ring and the shaft. So, that small space we have to accommodate the insulation which is sufficient for 33 divided by root 3, this much kV. So, it is around 19 kV. So, we have to provide insulation also. If we are keeping the armature stationary, in that case this requirement will be eliminated. We are having a stator on the outer side and we can easily take out the connection, no need of slip ring, no need of slip ring for extracting the AC power. Of course, in that case we will need we have to feed DC to the rotor. Right now we are discussing the case where armature is rotating and field winding is kept on the stator. So, inside the stator we are having limited space. In that limited space we have to accommodate 3 slip rings having capacity of around 5000 ampere and the insulation level of around 20 kV. So, it is somewhat difficult. Now, we will discuss the requirement of slip ring for DC also. So, in case of DC, suppose what we have to do? We have to simply excite the field winding at the voltage level of only 500 volt, and the field winding is suppose it is having capacity of 1 megawatt. So, what will be the amount of field current? 1 megawatt means 1 into 10 raised to power 6. We have to divide it by 500 volt. So, 200 ampere is the requirement. Compare, in that case we were needing the requirement was 5000 ampere. Here the requirement was only 2000 ampere. In that case insulation was around 19 kV, 20 kV. In this case half kV only, 500 volt. Requirement was 3 slip rings. In case of DC only 2 slip rings are required. So, finally, it is resulting in great economy, and in engineering we have to take care of all these aspects. So, economy is one of the major advantage. Now, the second advantage, increased efficiency, losses will be less. Yes, can anyone answer about this question? Why the losses will be less? Yes, reduced slip ring losses. When number of slip rings are reduced, so losses at the slip ring it will be minimized. At the same time, wear and tear is also minimized. When we are using slip rings, we have to use the brushes. In case of DC, we have already seen in earlier classes of when you have gone through the DC generator, commutation is the one of the biggest problem, and wear and tear between the commutator and the brushes. And similarly here we have to use the brushes also. So, another advantage is better insulation. If the armature is kept on the outer side, we can easily provide the insulation in better way. Cooling is also efficient when the armature is stationary. When we are placing armature on the rotating part on over the shaft of this machine, it will become bulky. If we are providing field on the rotor, it is having very light weight. So, reduced weight is one of the added advantage. Again, if weight is reduced, wear and tear will be less. Armature is on the outer side, there is no need to rotate the conductor. So, construction will be rigid. So, these are the some of the advantages of keeping the armature stationary and the field rotating. If we discuss the frequency of generated EMF, we are having the relation F is equal to Pn divided by 120 hertz. So, suppose for 50 hertz, what will be the number of pole? It can be calculated by P is equal to 120 into 50 divided by N, N is in RPM. So, 6000 divided by N. So, if we want to generate AC power of certain frequency, we have to take care of the balance between the speed of rotation and number of poles. So far we have discussed armature is kept stationary on the outer part, rotor is field winding is placed on the rotor. Now, there are two types of possibilities. Either we are using salient pole type structure. Salient pole means the poles are clearly projected. We can see this is north pole, this is south pole, this is again north pole, south pole. So, according to number of pole, we can fix the poles on the rotor, and then the field winding will be there to excite them. At the top of the poles, we are having provision of damper windings also. So, in case of salient pole, the air gap will not be uniform. We are having another type of structure which is cylindrical rotor. In case of cylindrical rotor, the gap is throughout uniform. Now, when we are generating huge amount of power, definitely we have to dissipate the energy, we have to dissipate the heat energy, and we have to make certain arrangement for cooling. So, in large alternators, we are having provision of closed circuit cooling. We can use air cooling, water cooling, hydrogen or helium cooling is also used in alternators for cooling purpose. Now, the alternator may be single phase alternator or it may be 3-phase alternator depending on the requirement. And if you are running one single alternator, the output frequency, the speed of the frequency of generated EMF will be directly dependent on the speed of the alternator. Let me clear this point once again. If we are using single alternator, we can run it on any speed, and according to that speed it will generate the frequency. Whereas, in case of synchronous motor, what we are doing, we are feeding 3-phase power to that synchronous machine, to the armature of that synchronous machine, and the speed of rotation will be according to the speed of frequency of the input supply. If we are having a 4-pole synchronous motor, we are feeding 50 hertz supply, then the speed of the rotation will be 1500 rpm. It will rotate at a speed of 1500 rpm. Now, we will derive the expression for generated EMF. Consider one alternator. There are 4 possibilities. Outer part, it is having armature winding, field winding is on the central part, rotor, and the rotor is cylindrical type, first case. Now, we are having second category. Again, the armature is kept on the outer part, which is stator. Field is rotating, but on the rotor we are having salient poles. In first case, the armature was on the outer part, the rotor was cylindrical type. In second case, again armature was on the outer part, the rotor is salient type. In next 2 categories, the scheme will be opposite. Field winding will be on the outer side, stator, and inside this the rotating part will be armature. But in all the cases, what we have to consider, the relative motion between magnetic field and the conductor. Suppose we are having the outer part, we are placing one coil A and A dash, field coil, the armature coil is there. If one coil is placed on the armature A dash as shown in the figure, you will see the field is passing axis of stator. Now, the rotor inside it is rotating, so it may take any position. Suppose at the time of t is equal to 0, what will happen? The axis of the field will be coincidence with that stator field. So, both the field are coincident at that instant. So, all the flux they are linking with the coil. The flux passing through that coil will be maximum at that instant. Maximum means it is equal to phi cosine 0. Angle theta is 0. Theta is the angle when the rotor is rotating at a speed omega r radian per second. In time t, it is making some angle with the axis of stator. So, in the diagram you can see theta is equal to omega r t. The rotor is rotating anti-clockwise direction. So, flux linkage at any time, flux linkage between the full pitch winding having n number of turns. So, psi is equal to n multiplied by flux passing through that coil at that instant. So, psi is equal to n phi cosine of omega r t, and according to Faraday's law of electromagnetic induction, E is equal to minus d psi by dt. So, if we solve this, minus minus it is coming to plus. So, n phi omega r sin omega r t minus n d phi by dt cos omega r t. The first term, it is known as speed voltage. In this term we are having n as speed. The second term, it is known as transformer voltage. Now, if we are having DC excitation, in that case d phi by dt will be 0. So, second term is going to be 0. So, what is instantaneous value of generated EMF? Small e is equal to n omega r phi sin omega r t. When this sin theta is equal to, what is the maximum value of this sin theta? When it is equal to 90 degree, it is going to be, it will be equal to 1. So, E max is equal to n omega r phi. In case of sine wave, we know that the RMS value is maximum value divided by root 2. So, on solving it is coming as root 2 pi Fr n phi. Now, what is Fr? Here Fr is the speed frequency or rotational frequency. Fr is given by P Nr divided by 2 hertz, where Nr is the relative speed in RPS. So far we have seen some constructional detail and the generated EMF in case of alternator. When the alternator is running at no load, the generated EMF is equal to no load induced EMF, say EF. When some load is connected, now this load may be resistive in nature, it may be inductive in nature, it may be capacitive in nature, and depending on the loading, we will get some terminal voltage Vt. So, EF minus Vt upon Vt into 100, this is the percentage voltage regulation. Voltage regulation of alternator. We are having different methods of determination of this voltage regulation. One is EMF method, then MMF method, ZPF method, Portier triangle method. Some other methods are also there, new ASA method. So, if the regulation value of the regulation, if the result is less, then it means regulation is better. If this figure is coming, it is having some larger value, then we will term it as poor voltage regulation. As far as the application part is concerned, anywhere if we have to generate electricity, in all the thermal power plants and all the hydel power plant, nuclear power plant, where we are generating the energy, we will need these alternators. Apart from that, in vehicles we are using alternator to charge the battery. it is easier to convert this AC power to DC with the help of rectifier instead of using DC generator at that place. So, we have seen the derivation for generated EMF of alternator. In that case, we have considered one conductor A and A dash. So, only one full pitched coil was considered. If we are having 3-phase alternator, we will be having A dash, then B dash, then C dash. These 3 coils are 120° apart in space, 120° electrical apart in space. Now, generally in alternator, the entire winding is not concentrated on these 6 slots only, whereas it is distributed uniformly over the periphery of the stator. And there are certain advantages of this. The output wave, it is free from harmonics. So, reduction in harmonics is one of the advantage of this distribution of the winding. Second advantage is full utilization of iron part and the copper. Third important part is rigidity to the armature stator design. Of course, when we are using concentrated winding, in that case generated EMF will be more. If we are distributing some of the turns on the adjacent side, then EMF induced in that coil, particular coil, will be somewhat less than the coil which is at the very center. So, there will be one term, distribution factor, it will come in picture. Generally, 2 things are taken care during the design. One is distribution of the winding and second is the short pitching. We are reducing the coil span. The coils are not 180° apart. The coil span is reduced somewhat. So, it is resulting in saving of copper. At the same time, the harmonics are eliminated. The output wave is pure sinusoidal wave. So, finally, one more factor will be added in this derivation, Kw, which is known as winding factor, and winding factor is nothing but product of Kc and Kd. Kc is cording factor and Kd is distribution factor. Generally, the value of this winding factor is around 0.9. So, with sacrificing little amount of generated EMF, we are getting stability, rigidity in the structure, saving in copper, elimination of harmonics. So, these are the added advantage of the this design. So, instead of full pitch, we are using short pitch coil. Instead of concentrated winding, we are using distributed winding. So, at the end, we have to summarize the lecture. What are the possible questions generally coming in the mind? Write an expression for generated EMF at no load in one phase of 3-phase alternator. Yes, EPH, EMF per phase, is equal to √2 pi f NPH into phi into Kw. Kw is winding factor, NPH number of turns per phase, f frequency, f means it is rotational frequency. Now, we have discussed 2 factors, pitch factor and distribution factor. So, define pitch factor. The pitch factor is defined as resultant EMF of a corded coil divided by resultant EMF of a full pitched coil. It is equal to Kp. The the distribution factor, it is termed as Kd, and it is defined as phasor sum of coil EMFs divided by arithmetic sum of the coil EMFs. So, in today's class we have discussed the working principle of alternator, the constructional detail, generated EMF. In next class we will be discussing working principle of synchronous motor. So, some of the terms which we have discussed today, they will be referred in next lectures also, because basically it is synchronous machine. If we are feeding mechanical power, output will be electrical and it will work as alternator. If we are feeding electrical energy, output will be mechanical, the rotor will rotate at constant speed and it will be synchronous motor. In next class we will also compare synchronous motor and induction motor, what are the similarities and dissimilarities among the between the synchronous motor and induction motor. Thank you very much.